Okay, so we're going to prove that opposite sides of a parallelogram are equal. Basically, we're going to show ABCD is a parallelogram if and only if AD is congruent to BC and AB is congruent to CD. So let's go ahead and start the proof. So we know this is an if and only if statement. So we're going to do P implies Q first. So we're going to assume A, B, C, D is a parallelogram. Okay, so we know a quadrilateral is a parallelogram whenever we have the opposite sides are parallel. So this implies that AD is parallel to BC and AB is parallel to CD. Next, what we're going to do is we're going to draw a diagonal. Okay. Okay. So we have that diagonal BD. So we'll draw diagonal BD. Okay. So since we know AD is parallel to BC, so AD is parallel to BC. This implies, by the alternate interior angle theorem, since now we have a transversal between two parallel lines, we know that this angle here, angle ADB, is congruent to angle CBD, right? So this implies that angle ADB is congruent to angle CBD, right? And we also know that since we have AB is parallel to CD, this implies by the alternate interior angle theorem that angle, so this angle here is CDB. We know that CDB is congruent to angle ABD. Right? So what we have here is we know these two triangles are congruent by the angle side angle congruency postulate, right? Because BD is shared between both triangles. So let's go ahead and consider triangle ABD and triangle CDB, right? So let's consider triangle ABD and triangle CDB. So we know that angle ADB is congruent to angle CBD. We know that BD is congruent to itself, right? BD is congruent to BD. And we know that angle ABD is congruent to angle CDB, right? So these three things together imply by the angle side angle congruency postulate that triangle ABD is congruent to triangle CDB, right? So if we have that this triangle is congruent to this triangle, that means the corresponding sides are congruent. Namely, AD is congruent to BC and AB is congruent to CD, which is what we wanted to show. So this implies that AB, right? AB is congruent to CD. And AD is congruent to BC. Right? So that's going this way. We assumed that ABCD was a parallelogram, and then we got to the fact that the opposite sides are equal. Now we're going to assume the opposite sides are equal and try to get to ABCD is a parallelogram. So, as you can see, I drew the picture already, and we're going to have the Q implies P, right? So now we're going to assume AD is congruent to BC and AB is congruent to CD. So we have this is congruent to this, and this is congruent to this. So like last time, we're going to draw diagonal BD, right? So we'll draw that diagonal BD. Okay. So we know that these two triangles are congruent by the side-side-side congruency postulate, right? And if these sides are, if these two triangles are congruent, that means that the corresponding angles are congruent, right? This will be congruent to this, right? And this will be congruent to this. And I'll show that in a second. So let's consider triangle ADB and triangle CBD. So I know that AD is congruent to BC. AD is congruent to BC. I know that AB is congruent to CD. And I know that BD is congruent to BD. So these three things imply by the side-side-side congruency postulate that triangle ADB is congruent to triangle CBD. And of course, that means that angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CDB. So we know that those two are congruent, and what we have here is we have this angle, we have these alternate interior angles congruent between these two lines, and we know by the alternate interior angle theorem that must mean that these two lines, right? These two lines are parallel and these two lines are parallel. So this implies that by AIA, the alternate interior angle theorem, that AB is parallel to CD and AD is parallel to BC. And then, of course, if we have a quadrilateral where the opposite sides are parallel, this means that ABCD is a parallelogram. And that is the proof, which is very useful because now we know if opposite sides of a quadrilateral are congruent, then we have a parallelogram. And we know if we have a parallelogram, then opposite sides of that parallelogram are congruent, right? So that is the end of the proof.